So proving an identity, you always want to use the side that looks more crazy. So definitely this side is the one that looks a bit crazy, the one on the left. So since the left side looks more crazy, we might as well use that one. And the way it looks here, it has, there's a double angle there, there's 10 there. So as mentioned, right, you only change if you feel it is necessary. But then the thing is with double angles, especially with cos, I mean, you're basically going to have to change. So without thinking too much of what to change here, down here we have a sine squared. This is going to have sine x over cos x. So, yeah, I think here deciding what to change the cos to x to is probably going to be the one thing that maybe has us spending a bit of time thinking, because yeah. But the other thing is we have down here, this can be written as 1 minus cos squared x. So already I'm thinking of what am I thinking of? I'm thinking of well, let's just not think. Let's just write, and then we can always change if we feel we need to change. You see, that's the beauty of this work, because if you choose, yeah.
But that's why I don't like it, because it takes so long. You need to figure it all out.
Well, that's the thing, that's why when you're writing an exam, you need to have stamina, otherwise you're gonna get tired easily. So that's why you don't want to be tired. That's why you don't want to be sleepy, because you're always gonna want to choose the easy way out so that you don't use energy. Because remember, when your brain is exhausted, it's always gonna choose survival. It's not gonna focus. It's just gonna want to breathe. It's just gonna want to pump blood to the brain.
Yeah.
So yeah. Anyways, having to have chosen this, right, it puts us in a situation where you see here we have to use brackets. We definitely have to use brackets. But then having to have written it out like this, yeah, it doesn't look very satisfactory. Yeah, it doesn't. But I mean, it is what it is. It is what it is. Actually, let me not multiply these out together, because I don't think it is going to be useful to us. Yeah, I don't think
I
so.
would say leave the sin over cos as a 10.
For now, right?
Yeah, because otherwise you might not have to do anything with it to get the minus 10.
Oh, ha 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 ha. Nice. Well, let's do that, because likely with trigonometry, we have freedom. We have so much freedom in trigonometry, because whatever you do, as I said, it's never a death sentence. You can literally always wiggle your way out. Like that's the crazy thing, that's why trigonometry, it's actually not that bad. It just has, a lot of enemies, but it's it's okay. So yeah, so far, yeah, it looks. Pardon?
And then if I was to get thinking, I would change the bottom one to 1 minus cos 2 to the power of 2x.
1 minus cos 2. Okay, let's see what that is gonna do. So you see here, we're just writing out what it is that you're thinking, right? So that we can see where it's gonna take us. And then if we need to reverse it, we can always do it, So this is one of
go reversed, but anyway.
so anyways, this is where we are, right? The bottom part can eventually, maybe this is the difference of two squares, but then it doesn't look like it would cancel anything at the top. So I mean, so this is the fortunate thing. When you see that, okay, wait, this is not working, right? I mean, like, you have the freedom to just maybe restart. You can maybe even change this to something different. Maybe even
change that to a cos.
Okay, let's see. Cos squared here minus sine squared here, right? So the way it's looking, yeah, let's actually do the fraction thing, because with the if you're gonna change the 10 to a fraction, right, what's gonna happen is the following. When you're able to work with fractions, you're almost invincible because let me show you. So this is, you can put over 1, right? This you can put as cos x, sine x over cos x. And then the bottom here is the sine squared x. Sine squared x. So if you think of it nicely, right, we don't have to mix too much. We just have to remember that this times this, just paste them together. Don't multiply out anything. We don't have to because it's a bit unnecessary. We're going to end up with cube and all that, you know. That's not useful in trigonometry. So this, right, is over cos x. So the one thing I want to do is, you see here, this whole fraction is being divided by the cos squared x. So let's write it next to it here. Divided by cos squared x. Sine squared x, sine squared x. Let's put it over 1. The reason for doing this is so that we can tip and multiply. So if you flip over that other number, so here you see here, we're working with this thing here. We don't have to do anything because it's really not necessary. And then down here, we still have our cos x. This we can flip it over now, 1 sine squared x, you see. So the reason for doing this is so that you see that what you have at the bottom can eventually cancel each other. Not all of it, but the sine x there. So I'm just rewriting everything nice and slow so that you can see it nicely. So at the top, we have this, right? And at the bottom, we have cos x times, wait, what? Is it a cos x? Yeah, cos x times sine squared x, you see? So that now you can see, okay, all that's happening is this can cancel this. The reason these can cancel is because you see, this has been factorized already. This is also low key, you know, it's one thing, so it's fine. And then at the top, we don't have anything anymore. This we could have even, it looks like we
Doesn't
put it,
that change to a 1?
if it was plus,
Or
if they were both positive, yeah. And it's looking like this, we might even eventually have to, we'll see what we'll do with it. See, because remember, nothing is set in stone in trigonometry. If you need to change it, you can always change it. So this is like cos x times sine x, like this. Do you see it?
Yeah.
Yes. So this is actually looking very interesting, like very interesting, because it looks like this is one of those questions where, let's see here. It looks like one of,
Yeah, never mind. It's not gonna work. Never mind.
well, it is. Remember, this is 2 terms at the top, right? So this is where you have to get creative, because remember, we have a minus here, and our other side has a minus here. And then we have one term and another term at the top. So remember, each term can be written individually. So cos squared x, you can write it with cos x here, sine x there. Same this one. Sine squared x here, cos x here, sine x here. So here now, one cos can cancel one cos. You're going to have cos x over sine x.
And then the sin cancel out.
And then you can have sine x.
10.
Yes.
Ach, nee. For 5 marks. This was longer than the one for 7 marks.
Well, you see, that's the thing, you know, you don't, I understand why you would think like that. It's very understandable. But you see, the only way we were able to now break down this question so nicely is because we didn't bother to like cut corners. It's only when you feel like you need to go from zoop and then maybe zoop and then zoop that your brain starts to get messed up. You see, because with trigonometry, that's how you're going to safeguard yourself from making mistakes, right? You just want to take your time, you know, take your time. Don't feel like you need to rush. That way you're going to spot small errors and all that.
The
Yeah.
plan already is to do analytical, Euclidean, and trig.
Yeah, bro. Yeah, bro. Yeah, bro. It is what it is. It is what it is. Let me
In
see
the
here.
exam, because I was laughing yesterday, Levi. I
Mm,
looked at the number patterns because we get 10 minutes reading time. And I was like, okay, I'm doing you last.
okay, I feel you. I feel you. I feel you.
And then I was
Mm,
laughing as well because I was sitting there and then I was
mm.
figuring it out. I don't know how, but I was figuring it out. So I was very happy with that.
Nice, man. Nice, nice, nice. So with this last question, right? The fortunate thing is, I just want to show you something.
Yeah,
This is
those ones are becoming common.
yeah, yeah, it looks familiar. So if I can check here, trigonometry course memo. Let me see here. Yeah, this one is one of the questions there
Okay, I'll have a look at it.
somewhere.
Because the maximum and minimum values I struggle with.
I hear
Um,
you. I hear you. So I just want to point out where we would find that question because it definitely looks familiar. Because this is in the trigonometry course, right, on the dashboard on the
yeah.
course platform. So let's just scroll here. I was gonna see here something scrolling. Oh wow, dude, dude. Oh wow. You know, it's the funny thing, right? This question came from someone had sent it. They had to do it at their school, but it's
Okay.
fine.
I
But
was gonna I was gonna wonder, where do you get all these sums from, Eva? Like what resources? You from past
the,
papers or where?
yeah, they're literally all over the place. You know, the internet is a big place. You know, so normally if you dig for like questions to like practice with and all that, you know, you find everything, and it's usually then a matter of just picking out what looks like something that looks like an examiner would pick out. So this is like an example looking similar to what we have. This one is actually maybe even a bit different because you see here you have sine. They said given the expression, calculate the maximum value of the above expression. So there's sine to x here, cos to x. So here I wrote here simplify until you have one trig ratio. Oh wait, it is. We have looked at this question, and then it
Yeah,
says calculate the maximum value of
this
the
was in my
expression.
other assessment.
Oh yeah, yeah. So with this one to start off, right, you would have something like here, you know, this is like 1 sine x times cos x. Let's actually maybe make this like a separate one so that it's not too, to here.